Hello everyone. In this work, we present a system for few-shot talking head synthesis. Given a single or few-shot images of a source identity and the facial landmarks of a target view, we break down the image synthesis process into two steps. First, we predict a discrete but dense spatial layout for the output, which is then used to synthesize the final image. So why is this factorized representation useful? First, it partially disentangles spatial and appearance information. This results in better identity preservation and enables learning a strong prior of head shapes, which yields higher robustness to pose variations. Second, having a spatial layout enables using better image synthesis architectures that utilize spatial denormalization layers, such as SPADE. Spatial denormalization layers, or SPADE for short, was introduced by Park et al., but requires the availability of spatial inputs like semantic maps. But accurate semantic labeling is expensive and even non-existent for novel head poses in our setting. So instead, we learn to predict dense spatial maps that are multi-view consistent with respect to the head movement and facial expressions. We also aim at learning a latent spatial representation that is better suited to SPADE than traditional semantic maps. This is a brief overview of our training. We first bootstrap the training of our layout generator using Oracle segmentations obtained from the ground truth images. Then, we turn off the semantic segmentation loss and train our full pipeline. This allows the layout generator to deviate from predicting semantic segmentations, and instead, it learns a latent spatial representation that proves to be superior for the quality of the final synthesis. There are several key advantages to our approach. First, our subject-agnostic model performance is not only better than the subject-agnostic baselines, but is on par with the subject-fine-tuned baselines. Second, we're able to achieve better subject-fine-tuned performance with significantly less data. For example, our subject-fine-tuned performance with 4-shot inputs is better than the fine-tuned baselines with 32-shot inputs. Also, our method achieves better identity preservation and is more robust to pose variations than the baselines. Here, we show a comparison in the single-shot reenactment setting. We show our performance with and without subject fine-tuning. Note that our method preserves the source identity better under different driving subjects. Here are the same sequences for another source identity. Note that our method, as well as the baselines, suffer from some temporal jitter, since the training does not enforce temporal consistency. Here, we show the effect of increasing the number of K-shot inputs as well as applying subject-specific fine-tuning. Our method shows good performance even in the single-shot scenario. The output quality improves with more input shots and further improves with the subject-specific fine-tuning. Here is another example. Note that while the baselines require subject-specific fine-tuning to retrieve the source identity, our method does not require that, although it still benefits from the fine-tuning to better reconstruct the background and other fine details. Here are some more results. Please note that all test identities were never seen during training. Here, we test the generalization of our model. It exhibits reasonable generalization capability to out-of-domain data, but requires pre-processing them to resemble the training data. Last, we conduct an ablation study of the importance of different components of our system. We start from a unit-based baseline that directly translates the facial landmarks to the final image. Changing the architecture to SPADE, conditioned on the sparse landmarks, improves the general quality of the output. Conditioning SPADE on learned semantic segmentations slightly improves the reconstruction of facial details. And finally, our learned spatial representation achieves the best performance. Thank you for listening. Our code and data are publicly available.